All right, we're beginning with Unit 4 here about simplifying radicals. This material should be familiar to you. Hopefully it'll ring a bell, but if there's some new stuff, then you'll be able to pick it up from here. So a radical sign is the symbol that you're used to seeing for a square root. Square root is defined as a number multiplied by itself 2 times to equal the radicand. The radicand would be, so let's say we have a third root, right? A third root of 27. The radicand would be the part that's underneath the radical sign, and then the index would be the part that is inside the radical symbol. So if there is no index, then it's determined to be a square root, or meant to be a square root. And if there is a different number in there, then we have a different kind of root. Perfect squares are the 20 that you see here, and there are plenty more perfect squares than this, but these are the 20 that you should all know by heart. If you say you know up to 12 squared, or maybe even up to 15 squared, it would make sense for you to learn the rest. I think that would help you. So spend a little bit of time with those. So the reason for simplifying radicals, you may want an exact answer when working with square roots. If you put it into a calculator, you get an approximation. So by simplifying, we have what's called an exact answer. Procedure here is to look for perfect squares as factors and rewrite the number under the radical as 2 factors. So we just split a number into 2 different factors. You rewrite them as 2 separate radicals. Then you take the square root of any perfect square factor and you multiply that root by the reduced radical. So you end up with a root and a non-root. So the simple radical form would be the product of a number and the remaining radical when there are no more perfect squares. So an example of simple radical form would be something like 3 root 14. A non-simple radical form would be something like this, 126, because that can be split apart and simplified. All right, so let's do some examples here. If I take root 18, I can split that into 2 different roots, root 9 and root 2. I could also have done 6 times 3, but remember I want to get a perfect square factor, so I'm looking for ways to rewrite 18 using a square number. And I'll put the square number first so that when I solve this, it becomes a coefficient. All right, sometimes you start with a square number and then you can just write the result. The 80, so if you're not sure what square numbers divide in, you can start just by consulting your list of squares. So if I go back up to my list of squares here, factors of 80 would need to be less than halfway to 80, right? So I'm starting in here. I know that 80 doesn't divide by 25, so the first one I'd want to attempt is 16. And that does work. 16 times 5 is 80. So I can rewrite this as 16 times 5. The 16 solves, it gives me 4, and then the 5 stays inside. Now let's say you had thought, okay, well, 80 divides by 4, and so you split it up as root 4 and root 20. That's acceptable. You would have 2 root 20, but the thing is it's not fully simplified because the 20 can then split into another 4 times 5. And so that part there is 2 root 5. So the 2 that I had here and the 2 that I had here would combine anyway to give me 4 root 5. So the fastest way to do it is to find the biggest perfect square that is a factor. But if you don't find the biggest one, you can then keep going with your simplification. All right, when you start with a number in front already, then that number would just be part of the answer. So if I simplify root 9, I get 3. And so 5 times 3 is 15. 98 is 49 times 2. So I can write this as root 49 times root 2. So the more familiar you are with your perfect squares, the easier it'll be for you to find these product pairs that has one that's solvable. So I solve the 49 and leave the root unsolved. So this is 21, root 2 as a final result. With fractions, sometimes you can reduce the fractions and sometimes the fractions contain square numbers themselves. So if I split this into root 4 over root 25, I can then solve both parts and get 2/5. All right. So on the top of page 2, there are some for you to try on your own. I'd like you to pause here and try those. All right, what we should end up with as final results here are 2 root 2, 12 root 6, and 3/7. All right, and on the future ones, I will ask you to pause and do those again. So do try that. It does help to know whether you're getting it or not. All right, when we want to multiply radicals, we can multiply any coefficients that are in front. We can multiply any radicands that are underneath the symbol. and then everything goes into one root. So for example, 1 here, I could do 5 times 2, because those are both coefficients. I can do 6 times 2, because they're both radicands. Now I try to simplify the 12. So I have 10 rather, times root 4 times root 3. I'm just splitting the 12 into 2 factors. Solve the 4, and then 10 times 2. All right, same thing here. I go 3 times 4 is 12. 5 times 7 is 35. The only way that 35 can be split is 5 times 7, and there's no sense in doing that because neither one's a square number. So if you don't have any factor pairs that are squares, just stop there. And number 3, so this one's interesting because I have variables now. The way you handle variables is you divide the powers by 2. So the 36 just equals 6, I know that. The 14 divided by 2 would give me 7, so I have x 7. The y divided by 2 would give me 13, and the z divided by 2 would give me 25. Now, I'm going to put one up here that is not such a nice situation. Let's go with a new one that says 40 and x to the 5th and y to the, let's go with an even number for the y. Now the 40 would split into what would be 4 times 10, right? Because I want a square number. The x, what I would do is go to the next even number down. So since I want to divide an even number by 2, I'm going to call this x4 and x1. And then the y can stay y8. So what I've done is I've split the number into 2 factors. I split the x into the next lowest even number and a 1, and the y stayed this way because it was already even. All right, solve the 4, you get 2. Solve the x4, you get x squared. Solve the y8, you get y4. In the leftover ones, I have a 10, and I have an x. There are no leftover y's because it was an even power. So that's how you would handle the variables if they did not divide out nicely. And that's what you're going to do on number 3 when you try these on your own. All right, so pause here. Try numbers 1, 2, and 3. Okay, we should have 18 root 2. We should have 12, and we should have 4, x10, y5. Wait a second. Yes. Z, sorry, I had the wrong variable there on my paper, z7. And then I have inside the root of 3x. So if you got any of those wrong, just make a note of it and we'll work on it together. All right, dividing radicals. So we can certainly reduce coefficients. So 9 divided by 3 would be 3. You can also reduce radicals if they're both roots, right? So you couldn't reduce the 125 with the 3, but you can reduce it with the 5. When you reduce roots, it stays a root. So 125 divided by 5 is 25. That will stay a root until you actually solve it. Since this is a perfect square, I can just write 3 times 5, and my result is 15. So that can be a fast way to do it. If you have a square number in the fraction, you can solve it, but that creates an issue with the denominator that we'll get to on the next page. So let's stick with reducing this for now. So I reduce the 8 and the 4, I get 2. I reduce the 36 and the 3, I get 12 inside the root. And then I'm going to split the 12 2 ways. So I'll have 2 root 4 root 3. Solve the 4, and I have 2 times 2 root 3. And so my answer is 4 root 3. Okay, so I reduce the coefficients, I reduce the roots, keep it as a root, and then simplify from there. All right, so try numbers 1 and 2 here. We should have, if you've paused it and tried it, we should have 30 for number 1, and we should have 8 root 3 for number 2. Okay, and on to page 3. Notes at the top. In order to add radicals, you have to have like radicals. So you cannot add radicals that are not the same. Same thing with subtraction. What you're going to do is simplify any radicals in the expressions. So we do that using the same technique of splitting into factors. We're going to add or subtract any coefficients when the radicals are alike, and then those radicals stay the same. Kind of like if you do 3x plus 4x. Sorry, there's no x there. 3x plus 4x, you get 7x. You don't change the x, you just add the coefficients. It's going to be like that for radicals too. If the radicals are different and there are no like radicals, then you can't go any further. So we just stop there. All right, so if I have root 45, I'm going to split that into a 9 times 5. That gives me 3 root 5. I have 4 root 20, so the 4 stays. 20 becomes 4 times 5. Solve the 4. I get 4 times 2 root 5, and that's going to be 8 root 5. So I've just simplified each radical separately. Now I get to the point where I have like radicals. I have 3 of them and 8 more of them. Totals 11 of that root type. So 11 root 5. All right, moving on to this next example, we have 5 root 8, which I want to rewrite as 5 root 4 root 2. And the next one is just minus 4 root 2. If I solve the 4, I get 5 times 2, so 10 root 2 minus 4 root 2. And then I can combine those because they're like radicals, so it would be 6 root 2. With this one, I can't simplify the 3. I can't simplify the 2. And I can't add the 3 and the 2 because they're not common radicals. So I just need to say that this is already simplified. And that will occasionally come up, already simplified. All right, and then you have these to try on your own. So pause and do that. All right, we should have 14 root 3. We should have minus 6 root 7. And we should have 9 root 5. All right, on to the last section here, rationalizing the denominator. So it's not considered proper to have a radical sign in the denominator of a fraction. So to get a radical out of the denominator, you have to rationalize it, which means take an irrational number and make it rational. So the procedure, it goes like this. Whatever root is in the denominator, that's the root you multiply by. And because we need to keep the fraction balanced, we need to multiply both top and bottom so that this fraction we multiply by is equivalent to 1. So if I multiply root 5 times root 5, I get root 25. And if I multiply 3 by root 5, I get 3 root 5. And so root 25 solves, and I have 3 root 5 over 5. Now I want to look at this answer and make sure there's no reducing that I can do. I'm allowed to reduce both non-roots or both roots, but I can't reduce one of each. So this doesn't work here. If the 3 was a 10, then I would reduce that. But 3/5 doesn't reduce any further, so I just leave it. All right, second one, multiply the denominator by the root. Same thing with the numerator. So my numerator would be 7 root 2. My denominator would be 3 root 4. Because remember, you multiply 2 roots together. And so I have 7 root 2 on top and 3 times 2 on the bottom. So I have 6 on the bottom. And we'll do another one here, times root 5 in both locations. So I have 10 root 5. I have 7 root 25. Now if I reduce this, all it's going to do is put me back to where I started. So I don't want to do that. What I want to do instead is solve the bottom. 7 times 5 would be 35. 10 times root 5 on the top in the numerator. And then try to reduce my coefficients. I can reduce them both by 5, so I get 2 root 5 over 7. Now this last one doesn't have a denominator root, but when you have a fraction within the square root, that's equivalent to saying root 6 over root 5. So I need to multiply by root 5. So I get root 30 on the top and root 25 on the bottom. So my denominator is 5. My numerator, can I split this? It would be 6 times 5. It would be 10 times 3. It would be 15 times 2. None of those have square numbers. So I'm just going to leave it root 30 over 5. And that's considered done. I can't reduce those because I have one of each type. All right, so the last part here to try these on your own. Pause first and then come back and check them out. Final answer for the first one is 3 root 7. Second one is 12 root 11 over 11. Third one is 7 root 5 over 5. And the fourth one is root 35 over 7. All right, that'll do it for today.